Welcome back, everybody. Today we have another S17 Pro boards, and this one was showing a little bit of special thing in the sense that it has corrosions on the board. So just something I thought I'd pick up the camera and show you guys how I troubleshot it and where to go from there. So symptoms when this board got to me, the whole heat sinks on the intake side were completely plugged up. So all these fins were completely filled with dust, and there was even like some bugs in there. So this was definitely one of the worst I had ever seen. So I did clean that up a little bit. There's still some leftover aluminum oxide. You can see that, like the white powdery stuff. But anyway, that's good enough for our purposes right now. The board on the tester is showing 44 ASICs. So I just did what I do usually, shorted my 1.8 volt around chip 44, and based on that, I ended up replacing chip 45 after checking that all the domain voltage was there, as well as the 1.8 and the 0.8 volt on chip 45. That did not solve the problem, so I went ahead and started looking at the signals between chip 44 and chip 45. And after a couple measurements, I noticed that there was something weird happening. And so this is where we are now, and I'm bringing you guys in. Let's switch to the microscope. All right, so this is 45. Let me just get you guys in focus. So this is 45, and here's 44. So as I was doing a little bit of cleaning with just a swab and some alcohol, I ended up, let me just get a pointing device, I ended up ripping this resistor completely off the board. So I was just like wiping around here and seeing if I could see anything wrong, and then this resistor completely got ripped off the board, and the pad underneath it was all like green and corroded, and you can tell there's still some like residue here of some stuff. So I ended up replacing or cleaning up the pads and putting another resistor on there. So as you can tell, this looks pretty rough, and you can also see the pad, like this pad right here, also lost like the solder that's on it, but so the pads under the resistor were all like green and really disgusting. So I went ahead and replaced that, and thinking that surely was the problem. And nope, that was not the case. So still at 44 ASICs found. And so I started troubleshooting some more, and I'll show you what I found. So if we look at the multimeter right now, I am on resistance, right? So if I go from the resistor that I changed to this point, so this is the BI signal, and you can see I got 1 mega ohm where I should have a total short, because this trace right here is directly connected between my two probes, right? So I should have 0. I have 1 mega ohm. So this is definitely where the problem is, or where actually one of the problem is. And also, as I was scraping the corrosion, then some of the solder mask, where am I? Yeah, right here. So some of the solder mask got chipped off. So it's like corrosion got into that trace too somehow and made that flake. So I'm actually gonna take advantage of that and use that as a test point. So now I want to find out where the disconnect is, right? So I know, sorry guys, I'm trying to get you in good focus here. All right, so I know that. So between here and here, I got 1 mega ohm. So here's another test point here that's on that same trace. I got that same value. So that tells me that the trace here is good, right? So I got, this is the resistance in my multimeter leads, so that's good. And so that tells me that the problem is somewhere between the two test points that I'm touching right now. And so because I have the opportunity to use this as a test point, there we go. So I'm good here. And so the problem is somewhere between this test point, sorry, left hand, there we go. And no, I'm not quite touching it. There we go. And see, now we're down to, oops, we were down to like 0.9 megohms. So let's try to get that value again. Sorry, this is really hard for me with that angle. Come on. There we go, so 0.9. So that tells me that the problem is somewhere between those two. Now I can visually see here. Let me zoom you guys again. Right, so at the bottom here is what I was using as a test point, this little part of copper. And here was the other one. So visually we can see between the two, this all looks fine, this trace. So really for me, this pad is suspicious. And I mean, it's a little mangled up from me probing it, but other than that, it looks like it's connected, I think. And again, this is the trace. Yeah, so this is the trace that ultimately goes to the test point, and that's again the BI signal. So what I'm gonna do, I think, is I'm gonna remove the solder. Let me fire up my soldering station. I'm gonna remove the solder off of that test point, or that resistor pad, which doesn't have a resistor, it's just an empty placeholder. And then I'm gonna see what I can see. And maybe it's just gonna be a matter of bridging the trace so that it connects again, or maybe there's gonna be more to it. So let me go ahead and, so I'm using soldering braid or desoldering braid. I mean, this all looks pretty good to me. Let's have a look at, or let's do the resistance check again. Let me zoom out. All right, so between this pad and this exposed trace, still got 1 megohm. All right, so there might be something. The only thing I could see, like right behind that white paint, I'm just gonna gently scrape this. Just try to look for any sort of disconnect in this trace. And again, I don't see anything, so actually there's another. Aha. So I don't know if you saw, I used that this part of the exposed trace, and now I had a normal value. I had 0.3 instead of the 1 megohm or so. So something I probably should have done. Yeah, there you go. So something I probably should have done before removing that solder, but so between here and here, yeah, so this is where our megohm is. There you go, so 0.7 megohms now. So something's telling me that this trace somehow underneath this is damaged, or compromise in some way. So I'm going to try to gently try not to cause more damage than there already is, just because I'm curious and I would like to see it. Of course, I could just like put a big blob of solder on there and reconnect it and that would probably be fine. But I would really like to see it broken before I fix it. That's one thing that some people I feel are just, and not in this case, but in the case of ASICs, of like actual chips, people are kind of blindly changing chips without, confirming that the problem is there. And that's something that kind of bothers me personally, but I guess you're probably right, 90% of the time, so that's not too bad. Well then, oh yeah, here it is. So, no, maybe not. Okay, well, I was looking for a trace, and is it still in there? I feel like I should be there now. No, I think that's it. Yeah, I'm definitely deeper now. So, yeah, so there's officially no trace here between those two. Or maybe what was left was mostly powdery and I only scraped it away because we did have a value. Just try with another instrument, something a little bit more pointy. Oh yeah, so there's still some there. Let's look at what the resistance value says now. Between this and this. Sorry, I am all over the place. Okay, still got 0.8 mega ohms. So there's definitely something in there, but obviously not enough. So let's do a quick fix. Yeah, so what we could do right now, option number one, what I'm just about to do, put a big blob of solder on there to do the connection. Option number two would be to do a jumper wire. I don't know, these two are pretty far apart. I'm not sure I'm going to be able to bridge that. I just don't have the right iron to do that right now, but all right, let me switch to another iron. Yeah, so I was just saying, either use solder to bridge it, or if you have a wire or repair wire, which the one I have on hand I think is way too small for this repair. I'll try to show it to you under the microscope. Yeah, here it is. So as you can see, it's probably half that trace, maybe, not even. I mean, I could try to use it, I guess. And doing repair with something that you can barely see is quite challenging, to say the least. Here's one end. Here's the other. And I'm just gonna add a little bit of solder to that bottom part. There we go. Oops. And there we go. So let's give that a quick cleanup. But first, let me get rid of this wire. Just break it off like this. Now, of course, this wire is pretty fragile right now because it's so thin, so you want to be careful around that. And so as a final repair, I'm probably going to put a dab of silicone-based vibration dampening stuff on there just to give it a little bit of mechanical protection. All right, so there's still a lot on there. So here's our tiny wire, jumping the trace. So now let's do that same test again, resistance. See what we got between our resistor here and our pad there. So we got 0.4 ohms, which is good. And what about resistor here all the way to our test point over here? Same thing, so good. All right. So now let me move this camera over to the tester. And I realize that it is out of focus right now. So you might just have to bear with me. Let's just fire this up. Oh, board's not connected. Hold on. Oh, and now we're at 8. Well, we used to be at 44. Now we're at 8. Interesting. All right, more interesting. Yeah, more troubleshooting to do, I guess. All right, guys. Sorry, just kidding. I literally just turned the camera off and then back on, and then we're at 48 now. So did not do. Sorry, it's a little bit out of focus, but it says 48 anyway. So I'm gonna go throw that up in a miner and see what happens, and just go back. Stop this. Come back to the overhead. Yeah, so hopefully that was an example of some board corrosion for you. So something that isn't always obvious. Like visually, you couldn't even see it in this particular case. And hopefully that's something that you will keep in mind whenever you have some weird values that aren't always lining up with what they should be, or if they're different if you measure them one way from if you measure them another way, then it could be also a sign that you have something going on with either a trace or a component in between the two. And in the case of these boards, because they were completely plugged on the intake side, then it looks like this machine was sucking air directly from outside, maybe clearly unfiltered and maybe not in the best conditions. So and this trace would be the bottom of the machine, obviously, so maybe somewhere where moisture or water literally is more prone to do some damage to the board. So all right, hopefully you learned something. Thanks a lot.